In this example, we're going to look at copper 2 sulfate and sodium hydroxide. If we put 50 milliliters of 0.3 mole per liter copper 2 sulfate solution with an equal volume, so 50 milliliters, of NaOH, the initial temperature of both solutions is 21.4 degrees. After mixing the solutions in a coffee cup calorimeter, the highest temperature that is reached is 24.6 degrees Celsius. It wants us to determine the enthalpy change, which is delta H of the reaction, per mole of copper 2 sulfate, and write the thermochemical equation. So here, we know our first step is to determine Q with MC delta T. When we're thinking about the mass here, we have 50 milliliters and 50 milliliters that make up our solution, so we have a total of 100 grams. Our heat capacity of water, 4.184 joules per grams degrees Celsius, and our temperature is going to 24.6 degrees Celsius and starting at 21.4 degrees Celsius. Our heat in this reaction is equal to 1.3 times 10 to the 3 joules. We're going to convert this right away into kilojoules to get 1.3 kilojoules. Our next step is to take our Q of our system and find the delta H of our system by doing negative Q of our surroundings. So our delta H is equal to negative 1.3 kilojoules. We now need to find our moles. And from grade 11, we learned that moles is equal to our concentration times our volume. So we have 0.05 liters of copper sulfate, and we have a concentration of 0.3 moles per 1 liter of copper sulfate. This gives us a total amount of moles of 0.0150 moles. In our last step, we want to find the molar enthalpy of copper 2 sulfate. So we are going to take our negative Q over moles. So we have negative 1.3 kilojoules over 0.0150 moles, which gives us negative 89 kilojoules per mole. And if we are writing a thermochemical equation for this, we know that since delta H is negative, we write it on the product side over here, plus 89 kilojoules per mole.